Alright, next we're going to talk about how to actually read these graphs, how to get information on it. And you can see I've drawn here kind of a complicated looking graph, but let's take this apart piece by piece. Now when you look at a graph, the first thing you should probably look at are actually the axes of the graph. And here's what I mean by axes. This is the y-axis, this is the x-axis, and the plural of the word axis is axes. So when I say look at the axes, what I mean is look at these two lines here. And we have to determine what they mean. And if the graph is done properly, which remember this when you draw your own graphs, each axis will be labeled, telling you exactly what it's measuring. So here, the y-axis is measuring the position of the object, and it even tells us in what units, in meters. So when we look at the numbers here, if it's at 0, that means it is 0 meters from the frame of reference. Here it is 1 meter from the frame of reference, 2 meters, 3 meters, 4 meters, 5 meters. So this tells you how far away the object is from your starting point, or from your frame of reference, if you want to be more proper about it. The x-axis tells you how much time has passed, and it tells you that in seconds. So this is after 1 second has passed, after 2 seconds have passed, 3 seconds, 4 seconds, 5 seconds, 6 seconds, on and on. And if you'll remember from the introduction video, I said that one of the problems in describing motion is that you have to give the position, velocity, and acceleration of the object at every single point in its motion. And that would be a lot of writing if you tried to use words. But if you use a picture like this, you can tell that same story, including all the information, very, very easily. And so let's look at the type of things that we can do for this. For instance, if I ask you for the object of this motion, or for the motion of this object rather, where is this object after 2 seconds? That is, what is the object's position after 2 seconds have passed? All we have to do in order to do this is we go down to our time axis and we find 2 seconds. 2 seconds right there. And now we follow that up until we reach our line that describes the motion of the object. And then we follow that over to the y-axis, and that'll tell you its position at that time. So at 2 seconds, the position of the object was 2 meters from the frame of reference. And this works for anything. If I want to know where it was after 4 seconds, I go to 4, come over here, and the object was at 1 meter from the frame of reference at 4 seconds. Just to do another one, at 6 seconds, we follow that all the way up to the line, follow this all the way over, and the thing had a position of 5 meters from the frame of reference after 6 seconds. This works the other way as well. If I want to know the places where this, or at what time rather, this object had a position of 3 meters from the frame of reference, I go to 3 on the position axis, I follow that over, I follow it down, and I can find that after 5 seconds, the object was 3 meters from the frame of reference. So if I have a time, or if I have a position, this graph will let me find the other one. I just follow it to the line and then follow it over to the other side, and it will tell me that value. Now even more than that, and we'll get into more detail with this later, is that I can actually describe what was happening to the object by looking at this. At 0 seconds, it was at 0 meters. 1 second later, it was at 1 meter. So I know this thing is moving away from our starting point. And then at 2 seconds, it moves to 2. So it's continuing to move away as long as this line goes there. Now notice from here, it was at 2 meters at 2 seconds, and at 3 seconds, it's still at 2 meters. Well, if something was there, and then a second later it's still there, we can tell that it's not moving. So just by looking at the graph, you can tell that at this flat point here, the object was not moving. So it's kind of interesting to tell. If the line's going up like this, if it has a positive slope, I know the object is moving away from the frame of reference. If it has 0 slope, it's not moving at all. And if it's got a negative slope, it's moving towards the frame of reference. So again, I can take each spot. Here it's moving away from the frame of reference, holding still, moving towards the frame of reference, moving away, and moving back towards it. All of this simply by looking at the graph of the motion of the object. And later on, hopefully, you'll get a chance to graph your own motion and have a look at what this looks like in real time. All right, this was for position versus time. It doesn't always have to be position. We can use the same graph and look at it in terms of velocity. And now this same graph tells an entirely different story. At time 0, the velocity of the object was 0. At time 1, the velocity of the object was 1 meter per second. So what we see here is that the object sped up. Here it wasn't moving at all at 0, and now it's moving at 1 meters per second. So notice how changing what this axis was measuring changed everything about this. Here, at time equals 2 seconds, now it's moving at 2 meters per second. At 3, it's still moving at 2 meters per second. So now that means the speed didn't change, where before it meant the position didn't change. So be very, very careful as to what's going on here. Now this graph in particular allows me to find time and velocity. If I want to know how fast the object was moving at 4 seconds, it was moving at 1 meters per second. And using this information, you can find out just about anything you'd ever want to know about the motion of the object.